Hey there, everybody. So this is a continuation of the lesson from yesterday. I just want to give you some time to try and put the graphs together. So the graphs, I don't know if you've noticed here or not, but the way the graph works here, you want to have, I put a little note there. I think I forgot to mention it yesterday that, how far you travel depends on how long you've been traveling for. So we're thinking of the distance as your dependent variable, depends on time. So from grade 9 math class, your dependent variable is the vertical one, and your independent variable, the one that determines the other one, is your horizontal. And so hopefully you've tried to done your graph like this where you have distance and time as shown there. So what I'm going to show here is results from previous years where we've gone outside and used my vehicle and we line up along the road like I talked about and use the cruise control for uniform motion and then put the gas pedal on to do accelerated motion. And so this is what things looked like data wise for that. So these are just the handouts to get ready for it and so on. So results from uh, this isn't from, well, maybe this one is from 2014. Anyways, this is I have results from many years here, so this is just the one I have in the book in the lesson here. But these are just the times. I had it backwards at that point in time, and I fixed it to make it a little more logical. But the way it works is we go out and we line up in 10-meter intervals, right? And so at the time, I just had it organized like that and talked about dependent independent variable. For your handout, I switched it to make it a little easier to follow. So just ignore that little change there in the table. But yeah, nice even spacing, went outside, take measurements. We make the graph and it ends up being a nice, fairly straight line with some error, obviously, here and there. When we did when you do a line of best fit, that's something I didn't mention yesterday, but it's letting you sort of see what you can do to try and figure this out. If you've done a line of best fit already on your graph from yesterday, good job. That's great. That means you've applied your previous knowledge from grade 9. So from your line of best fit, pick out some nice spots, do some measurements. And so in this case, looks like around a little under 50. So I said like 48 in 4 seconds, which gives us 12 meters per second. And we want to convert to kilometers per hour because vehicle speedometers are in kilometers per hour, of course. Um, and so the conversion for meters per second to kilometers per hour, you have to think about converting meters to kilometers, but you also have to think about converting seconds to hours. So the meters to kilometers part, obviously we have like 1,000 meters is 1 kilometer. And so we're looking at like dividing by 1,000, right? So we have a 1 over 1,000 factor. And then seconds to hours, we're going to convert to minutes first by dividing by 60, and then to hours by dividing by 60. So we're dividing by 60 twice. And so there's really like a divide by 3,600 going on. So it ends up being here where we're going to multiply by 1 over 1,000. And in the bottom, we're dividing by 60, divided by 60. So it really ends up being a 1 over 1,000 and a 1 over 3,600. To divide by a 1 over 3,600, we invert and multiply. So it ends up being 3,600 over 1,000. And so really the conversion factor is 3.6. Right? Follow all those steps again, press pause as needed or whatever if I went too fast. Look at it again. But yeah, the end result is to go from meters per second to kilometers per hour. You're multiplying by 3.6. I like to think of meters per second as the unfamiliar one, and it's faster than you'd think. So we multiply by 3.6. So if I said to someone, can you run, say, 10 meters in a second? They might think, yeah, and then you multiply by 3.6 and be like, that's 36 kilometers an hour. Are you sure? Kind of thing. And then going the other way is dividing, of course. Okay. So that means that this fairly straight line, the pattern was we're going to multiply by 3.6 and get like 43.2 kilometers per hour. The actual picture from the speedometer when I did the activity was, that. It was like 41, 42, whatever. Really, really close. Okay? Each year, typically it ends up being pretty close. Now I don't have the data in here for the accelerated version. I forgot to copy that in, but basically you're probably going to have something like this where it's going to be, and we can't really do any further analysis at this point. I mentioned yesterday that hopefully it's uniform acceleration, meaning it's increasing its speed uniformly, but we won't be able to look at that quite yet. We'll look into that in the future about this. Okay, so basically we're left wondering certainly it's accelerating because it's think about here that in a time interval here, the distance changes by that much, and then in a same time interval, I should have made sure these were all same time intervals, but more carefully, were they? Or they're pretty close. I just kind of went across the page evenly, right? But in each time interval, so yeah, the displacement or the distance it's traveling is more and more and more, right? And so obviously it's acceleration, but we're just not sure if it's uniform acceleration or not. And that's going to be something we'll be able to look into soon. We just don't know how yet. I'm not covering it yet. Okay. So you should have two graphs like that from yesterday. Make sure, like go back and tweak them a bit if needed or whatever. Not don't fudge the data. I don't mean tweak them that way, but I mean just, if you need to make any corrections, like for example, you might not have drawn a line of best fit. It's super common for grade 9s, at least anyways, to draw the connect the dots routine, and that does not add any value. Unfortunately, just connecting the dots doesn't add any value to it for data analysis. Doing a line of best fit essentially determines an average for you of all of the numbers, right? So the average of all of the speeds, essentially, the line of best fit gives you, which is pretty sweet. All right. So yeah, finish up if you haven't yet or go back and correct if needed your graph and that from the other one yesterday. And then I just have officially here now the dot diagram stuff too that I could have just included yesterday, but here it is now. All right. Hopefully that's getting you thinking about motion and uniform motion and accelerated motion. And we'll be on our way in this new motion unit. Okay. That's it for now. Thanks for watching.